Okay, so page 75, graphing quadratic functions. Turn to page 72 so we can add to our objectives. So page 72, Unit 8 objectives. And we can do a quick recap of what we talked about last week. I believe it was last Tuesday. So last Tuesday we had a block schedule. We talked about two different things. This is 9.1, identifying quadratic functions. So we identified the quadratic functions. We determined if there was a minimum and a maximum and where that was located. And we found the domain and the range. And then we took a little break, did some in-class work, and then we came back to notes. We found the zeros from the graph. We found how to find the axis of symmetry of a parabola. And we found the vertex of a parabola. We're going to need these two last concepts that we learned last Tuesday to help us graph our parabolas. So today, we can graph quadratic functions. That is our goal for today. That is our objective. We're going to graph quadratic functions. William. Graph quadratic functions.
He's saying because it looks like it's a
It looks exactly like a B.
I could see that, but it's a G. Bless you. So we're going to graph quadratic functions. We're not graphing them. Page 75. At the top, graphing quadratic functions.
I'd rather graph it. Graphing is a whole lot easier than graphing. I don't graph quadratic functions.
You guys know I don't have exactly the most perfect handwriting. I know.
He just said this is what graphing is and wrote a B on his graph.
Okay, so graphing quadratic functions. We're going to have rules that we'll follow, steps that we can follow so we can graph our quadratic function. Our first step will entitle or encase kind of what we talked about last Tuesday. So our first step will be to use the vertex formula to find the axis of symmetry, or the AOS, and vertex. Who remembers what the vertex formula is? It's written probably on the left side of the paper if you have your book completely open. So who remembers the vertex formula? I currently have one person who remembers it. Desiree, what is it? So that's a minimum or maximum. The vertex, the formula we had, that it was x equals something. Avery?
0 squared. The average of the zeros.
That is where the vertex occurs. What's the vertex, the specific vertex formula? Noah? So our vertex formula is the negative x equals negative b over 2a. That'll give us our axis of symmetry, that line that whatever x equals, that vertical line that x equals. And it'll also give us our x coordinate for our vertex. So we're going to use the vertex formula to find the axis of symmetry in the vertex. Our second step will be to make a t-table and choose the two x values to the left of the vertex. So the two values in the negative direction of the vertex. So we're going to choose those two values and we're going to make a t-table. From those two values, those two x values, we're going to use the original equation. So step 3 is use the original equation to find our y values that correspond with our x values to the left of the vertex. That step is kind of what a t-table's definition is, but just to reiterate the fact that those x's will go with those y's, they will correspond. Step 4 is use the axis of symmetry. So use the AOS to reflect our coordinates. So we're going to use that axis of symmetry that we found to reflect, to give us 2 more points to finish out our parabola. And our last step is connect the points to create the parabola. Now, one thing we all need to listen up right here is the definition of a parabola or a quadratic function was that it's nonlinear. So when we're going to graph these, all the graphs that we've seen have had a curve. There's been no straight lines, right? So when we plot these points, it'll look like it'd be very easy to just make a V, just 2 straight lines. We need to remember that this is going to be a curved line. A parabola is a nonlinear line. That means it's curved. It has curve to it. So, I know I'm not an artist, and I know a lot of you guys are, or some of us aren't, but make sure that this line is curved. It's not straight. It's very important that we do not make a parabola straight lines. So those are our rules, our definitions, our steps to follow. Let's look through 2 examples, and then we'll get started on our homework. So our first example, the equation we're going to work with is y equals x squared minus 4x minus 5. So that is our first equation we're working with. Y equals x squared minus 4x minus 5. And now we're going to do what? What's our first step? What do we need to find? We need to find our axis of symmetry and our vertex, and we do that how? Good. No, we have the negative of -4 over 2 times what's our A. Important thing here also to remember, make sure that we're putting parentheses around what we're substituting in. Because our B value currently is negative, and we need the negative of that B value. So make sure that there's parentheses around our A's, our B's, our X's, whatever we're substituting in for. So the negative of -4 is 4. 2 times 1 is 2. 4 over 2 is 2. And that's our axis of symmetry. The line x equals -2 is our axis of symmetry. That is what cuts our parabola in half to 2 equal parts. So now that we know that x equals -2, we need to find our y coordinate. And how do we do that? Zach, we substitute it back in. We replace it back in. We found a value for x. Now we can substitute our value for x. So our original equation was y equals x squared. So our x was 2 squared. Minus 4 times our 2, which is x, minus 5. Excuse me. So we have 2 squared minus 4 times 2 minus 5. 2 squared is 4 times, or -4 times 2 is -8 minus 5. So that means our y coordinate equals what? 4 minus 8 is -4 minus 5 is -9. So our vertex is at 2, -9. That's what we've done already. We've known how to do that. That was Tuesday's second assignment. We knew how to find our axis of symmetry and our vertex. So this is where the new stuff kind of hits. We're going to go ahead and make us a table that has 5 lines. We're going to have our x and our y and our equation of y equals x squared minus 4x minus 5. On the third line, that's where our vertex will go. And our vertex was 2, -9. So that's 1 point that makes up this parabola. We need 5. And I said, what was our directions? Our step, I believe it was step 2. Choose those 2 values to the left of our vertex is x. So if we're going left on a number line and we started at 2, what's 1 to the left of 2? 1. What's 1 to the left of 1? 0. So we're going to use 0 and 1, the values to the left of the vertex, and get us y values. Let's start with 0, because that'll be pretty easy to find what the y value will be. So we're going to substitute that in. So we have 0 squared minus 4 times 0 minus 5. 0 squared minus 4 times 0 minus 5 is -5. Simple enough. Let's go ahead and substitute 1 in instead of 0. So now we have, bless you, parentheses 1 squared minus 4 times 1 minus 5. So 1 squared is minus 4, or minus 4 times 1. So 1 minus 4 is -3 minus 5. -8. So there are 3 points. We can go ahead and graph those real quick. So we're going to start with our vertex at 2, -9. And then I'm going to draw in our axis of symmetry of the line x equals 2. So this red line right here is our axis of symmetry. Now we're going to go ahead and plot the point 1, negative 8. And the point 0, negative 5. And this is a curved line. Make sure this is arrow at the end of it. So now we only have half a parabola with an axis of symmetry. How might we use the axis of symmetry to help us find more points on the other side? Step 4 uses the axis of symmetry to do what? Reflect it. So if we were to fold along that red line, we'd have the other half of the parabola. So if we were to fold, so we went up 1 over 1 here. So if we went up 1 over 1 here, we'd have a point. And that just so happens to be the point 3, negative 8. Similarly, with that second point, we went up 4 and over 2. So if we went up 4 and over 2 the other direction, we would have 4, negative 5. And now we have just created the other half of the parabola with only doing half the work. And then if we create, or we draw in that other half, that curved line, that parabola, we now have a full parabola. So do we see how we only have to find those 2 points to the left, and we can find those 2 points to the right using our symmetry and our reflection properties? So that kind of cuts the work down for you guys by 40%. Any questions on this first example? Let's try another one. So our second equation that we're going to work with today is y plus 3 minus 2x equals negative x squared. So now we need to find our axis of symmetry and our vertex. How are we going to do that? Zach. Good. Zach, notice its y is not by itself. A quadratic has to be in the form y equals ax squared plus bx plus c. Avery, take your head off, please. Thank you. So we have to have it in that form. So we need to, bless you, subtract that 3 over and add that 2x. So now we have a new equation of y equals negative x squared plus 2x minus 3. So we need to make sure when we get to our homework there's going to be a couple problems where it's not solved for y. And we need to make sure that it's solved for y, because then if it's not, that will affect what our vertex and our axis of symmetry will be. I'll come. Yes. Joel.
On that, wouldn't it be negative y? Subtracted it?
So we moved the 3 over and the 2 over. We didn't touch the y. So we subtracted 3, so it's a negative 3 over here. We added 2, so it's a positive 2 over here. So we have y equals negative x squared plus 2x minus 3. And now we can use our steps to get us our answer. So we start off by finding the axis of symmetry, where x equals what? Vertex formula. So we have negative b over 2a. What's that look like? So we have the negative of what b is over 2 times what a is. So the negative of 2 is negative 2. 2 times negative 1 is negative 2 over negative 2 is, and that's our axis of symmetry. Joel, the 2 on the bottom. So the vertex formula is negative b over 2a, so 2 times whatever a is. So the original definition of a quadratic function is y equals ax squared plus bx plus c. So the coefficient in front of the x squared term is our a, the coefficient in front of the x term is b, and then c is where it is. Our b? Our a is negative 2 because it's 2 times negative 1.
No, it's -2. No problem.
So our a right here, this coefficient of x squared is negative 1. The coefficient with the x term is 2, and that's our b.
Because you moved it across, Joel, right? The original problem is -2, but when you move it to the other side of the equal sign, it changes from -2 to positive. Right?
Does that answer your question?
And the formula is the opposite of b over 2a. B value is 2, the opposite is negative.
So now we need to find the y value for our vertex. We take our original equation and we substitute 1 in for x. So we have the negative of 1 squared plus 2 times 1 minus 3. I think I put one too many parentheses. We're good. So we have y equals 1 squared, 1, the negative of 1. Negative 1. 2 times 1, 2 minus 3. So y equals negative 1 plus 2 minus 3. So 1 minus 3 is negative 2. So remember, when we're putting parentheses around it, we have to put parentheses around it first because it's the negative of what x squared is. So our vertex is at 1, negative 2. Now we can go ahead and make that table. And on the third line, we can put what our vertex is, because that is the middle of 5. So we're going to choose the two values to the left. So what's to the left of 1? 0, and then negative 1. And then we're going to go 2 and 3. 1 Once again, let's start off with the 0 because that's easy. So we're going to substitute 0 into our original equation. That was y equals negative x squared plus 2x minus 3. So we're going to have the negative of 0 squared plus 2 times 0 minus 3. So if we, x value is 0, what is our y? 0 squared is 0 plus 2 times 0, which is 0, minus 3. Now, let's plug in this, substitute in this negative 1. Once again, need to remember that we put parentheses around what we're substituting in for x, or for a, or for any variable. So negative 1, the negative of negative 1 squared plus 2 times negative 1 minus 3. So, negative 1 squared. Negative 1 times negative 1 is 1. The negative of that, negative 1. Plus 2 times negative 1. So negative 1 minus 2. Negative 3 minus 3 is negative 6. So we can note from this example over here that 1, 8, and 3, 8, or 1, negative 8, and 3, negative 8 corresponded with each other, the y values, because they're one step away from 2 on either direction. So over here, 0, negative 3, what do you think the y value for 2 is going to be?
3.
Negative 3. What's the y value going to be for positive 3? Negative 6. So now we can go ahead and graph this. Starting with our vertex at 1, negative 2. Once again, I'll go ahead and draw in our axis of symmetry line of x equals 1 with the red pen. So there's our axis of symmetry line. Our vertex is right here. And then we can use our other points that we have found. So 0, negative 3. Right there. Negative 1, negative 6. Right there. And now we've mirrored it with 2, negative 3. And 3, negative 6. Avery, take the hood off. And now we can create our curved line running through those points with arrows at the end because they go on forever. And there we have two examples of graphing parabolas, graphing quadratic functions. Are there any questions? Joel? Yeah. Any questions? I will pass out a piece of paper that has coordinates already on it. All of our homework problems fit in a 10 by 10 square coordinate plane. Did you get the table, Joel?